Okay, so the next question that we have here is basically the coefficients of 3 consecutive terms in the expansion of 1 plus a raised to the power n are in the ratio 1 to 7 to 42, and so you want to find n. So that's example number 9. And so you have the coefficients of 3 consecutive terms, the coefficients of 3 consecutive terms of the expansion of 1 plus a raised to the power n are in the ratio 1 to 7 to 42. And so you want to find what is the value of n. Find n. So basically the assumption that you can make here is that you can assume that the 3 consecutive terms as the solution. You can say that assume that basically that the three consecutive terms are the r minus 1th term, r minus 1th, rth, and r plus 1th terms, respectively, right? Respectively. And so you basically, I'm assuming that I am dealing with the r minus 1th term, rth term, and r plus 1th term, which is of course a safe assumption to make, no matter what the value of your r. When in the expansion of any, basically, in the expansion of any binomial, when you're dealing with basically 3 consecutive terms, the terms would be r minus 1th, rth, and r plus 1th terms. So that's an assumption that you can, of course, logically make. And so these terms, now we need to know what is the coefficients of these terms in the expansion of this binomial, right? So, and for that, for the same reason, we need to find the r minus 1th terms, the rth term, and the r plus 1th term of this binomial, and then see what the coefficients are. In order to find the r minus 1th term, so basically you know that t of r plus 1 generally what you can say, that if you have a binomial a plus b raised to the power n, and if you basically expand this, that the general term in the expansion of this binomial would be denoted by t of, if I'm not mistaken, I don't really know, I don't really remember, but I can take a look at my notes. That is t of r plus 1, right? That is t of r plus 1. So you can say that t of r plus 1 is is equal to basically n combination r, a raised to the power n minus r, b raised to the power r. That is basically generally the case with the expansion of n of any binomial using the binomial theorem, which means that basically t of that means that then, but basically when you're dealing with the r minus 1th term, then you can say that basically, so you're looking for t of r minus 1, and that is generally equal to t of r plus 1, right? That's generally equal to t of r plus 1. And that means that basically, and that is equal to, now from here you can basically find out what is the value of your r at r minus 1th term, right? Because over here you can see that r minus 1 is equal to r plus 1. Of course, you should or let's do it this way. Well, or let's actually to avoid confusion. So this I have to use r over here, and this formula has an r over here. So this is not the best way of doing it. So I'm going to just simply say that basically the terms that I'm looking at are the 8th term, a minus 1th term, 8th term, and a plus 1th term, right? So that assumption is much better than using r, right? So I'm dealing with a minus 1th term and the 8th term, and well, of course, a is again used here. So let's use something that is not used here. For example, the z minus 1th term, and the zth term, and the z plus 1th term, for example. This way you will not run into any problems. Now you can see that basically you can see that at t of z minus 1, which is z minus 1th term, at this term basically your r is equal to, this is equal to t of r plus 1, and therefore you can see that basically at this term z minus 1 is equal to r plus 1, and therefore z is, or basically and therefore r would be equal to, so I cannot make that assumption either, right? So let's do something else. What we will do is that we will basically expand the a plus b raised to the power n once, and take a look at the expansion of a plus b raised to the power n. So if you expand a plus b raised to the power n, you will get n combination 0, a raised to the power n, b raised to the n minus 0, b raised to the power 0, plus n combination 1, a raised to the power n minus 1, b b raised to the power 1 plus n combination 2 a raised to the power n minus 2 b raised to the power 2 plus all the way up to n combination n a raised to the power n minus n b raised to the power n. Right? So you can see that basically this is basically the first term of this expansion. This is the first term of this expansion. When you are at the first term, your r is equal to 0. When you're at the second term, your r is equal to 1. When you're at the third term, your r is equal to 3. Right? And that basically means that at any term that you are, the value of your r is one less than the term number. So that way we can solve the problem. Otherwise, you would confuse yourself really, because I found this, for example, yesterday as I was working on some problems, and again I forgot this. So you have to somehow teach your mind, or teach yourself the way that you deal with this thing. Otherwise, since there is r's everywhere, basically there will be some sort of conflict in your mind, and then you would not be able to think about this. So what that means is that basically at any term, your r is one less than the number of the term, and the general form of the formula for any term, for any of those terms, is n combination r a raised to the power n minus r b raised to the power r. That's simple then. Once you know what your r is, then you can calculate whatever it is that you want to calculate. So what that means is that now I'm going to just simply go back here and call these terms as we had called them before: r minus 1th term, rth term, and r plus 1th term, right? And now when I'm at t of r minus 1, so at t of r minus 1, t of r minus 1th term, my r is one less than the term number. The term number is r minus 1, so the value of r over there becomes r minus 1, becomes basically is equal to r minus 1 minus 1 less than that is equal to r minus 2, right? So I can say that the value of r at that term is basically r minus 2. So that way there is no logical problem here. Moreover, I can say that basically at t of r, which is basically the rth term, then the value of r is basically, well, the one less than the term number, and this number can be anything. It can be r, it can be 1, it can be 2, it can be 1,000, it can be an algebraic expression, it can be anything. But whatever you see over there, subtract 1 from that, and that becomes the value of r that you use in this formula. It's that simple, right? So then you have basically r minus 1 over here, right? And at t of r plus 1, so at t of r plus 1, the value of r becomes 1 less than this, which becomes r, right? R plus 1 minus 1 is equal to r. Now that we have that out of the way, so to calculate now, we are basically expanding 1 plus a raised to the power n. We are expanding 1 plus a raised to the power n. So basically my index over here is my index over here is n, because index sometimes changes. It becomes 2 and it becomes 3 and it becomes, and it could be anything. It could be 2, it could be 3. The index is n. The a over here has become 1. A is equal to 1. And the b over here is equal to basically a. Right? So these are the values that you put in the formula, in this formula. And the value of your r, for t of r minus 1, the value of your r is basically r minus 2. Right? So that is the value of your r. And the formula that you use is n combination r, a raised to the power n minus r, b raised to the power r. Which simply means that t of r minus 1 is the same thing as n combination r, so your n is equal to n, combination r is equal to r minus 2, your a is equal to 1, so that's 1 raised to the power n minus r, which is n minus r plus 2, times b raised to the power r. So b is equal to a here, and raised to the power r is r minus 2. And therefore, you can write this as n combination r minus 2. This is just 1, a raised to the power r minus 2. Now the coefficient over here is basically n combination r minus 2. Therefore, the coefficient is equal to n combination r minus 2 for basically t of r minus 1. That is one part of this problem. That is one part. The next part that we have is we need to find the coefficient for t of r and t of r plus 1 as well. Okay, so now to find the coefficient of t of r. So to find the coefficient of t of r, if I'm not mistaken. So again, you have the same story here. Again, your index is equal to n, your a is equal to 1, your b is equal to a, your r is equal to basically 1 less than the term number, which is r minus 1. Your r becomes basically r minus 1. And the formula that you have is basically n combination r, this formula over here, n combination r, a raised to the power n minus r, b raised to the power r. So that means that t of r is equal to basically n is the index n combination r, which is in this case r minus 1, a raised to the power n minus r, so 1 raised to the power n minus r plus 1, and b raised to the power r, so b is a over here, and raised to the power r is r minus 1, which is the same thing as n combination r minus 1. This is just 1 times a raised to the power r minus 1. So again, the coefficient over here is basically n combination r minus 1. So the coefficient of t of r is therefore n combination r minus 1. That is basically that. and then to calculate the coefficient of t of r plus 1, to calculate the coefficient of t of r plus 1, we have basically, again, we have t of r plus 1 is equal to basically n combination r, so that would be n combination, and r here would be 1 less than the term number, so n combination r, a raised to, so a is 1 here, raised to the power n minus r, b, which is a here, raised to the power r, which is equal to n combination r. This is just 1, a raised to the power r, which means that the coefficient of t of r plus 1 is therefore n combination r, right? So now what we said before was that these coefficients are in the ratio 1 to 7 to 42. That means that I can say that n combination r minus 2, n combination r minus 2 to basically n combination r minus 1 to n combination r is equal to basically 1 to 7 to 42. 1 to 7 to 42. So that is basically the equation that we have, or the ratio that we have, and from this we want to calculate n. So what we can do is that I'm going to copy this thing, and in order for me to copy this I have to do a couple of arrangements. So I guess I will first have to select it, which is not this way possible. So I guess, no, I apologize for, okay. So you can copy it this way. Now you can select it and then copy it, edit, copy, and there is only copy here, okay. And then what you can do is that I need to create a new layer here, 111. My computer is a little bit slow. Okay, and now I have to basically make a selection here, and then over here say paste into selection, and then floating which didn't really happen. Okay, it didn't really happen. So there is something wrong right now. What we will do is we will go over here and hopefully we'll be able to make a screenshot. Okay, I will make a screenshot here, and then go over here. Now, we said that n combination r minus 2 by basically n combination r minus 1 by n combination r is equal to 1 to 7 to basically 42, right? That was the ratio. So I can divide, for example, I can say that based on this, I can say that n combination r minus 2, and divide that by n combination, for example, r minus 1, that would be equal to 1 to 7, right? And therefore, now I can solve this for basically, so based on this, you can say that n combination r minus 2 would be n factorial over n minus r minus 2 factorial times r minus 2 factorial times r minus 2 factorial, and divide that by n factorial divided by n minus r minus 1 factorial times r minus 1 factorial, right? That is basically based on n combination r is equal to n factorial, n minus r factorial, and r factorial. So that's based on this. I have written all of these formulas. Now, and then this is equal to 1 to 7. Now there is something regarding these, basically these fractions divided by one another, that I mean, it was really interesting to me that I didn't really know this myself. I mean, these are simple things that you're supposed to know, so it's very, it was actually very kind of shocking, interesting to me that I didn't know that. But you see over here, there are a few things that you usually do with these fractions. First, basically first is the problem of simplifying them. Meaning that, for example, you have some a divided by b, and then that you divide by, for example, c divided by d. These are two fractions that you have divided by one another. So once you have these two fractions, basically you can simplify a with c and b with d, meaning that the numerator of this can be simplified with the numerator of the one below, and the denominator of this can be simplified with the denominator of the fraction below. And the reason for that is that you can write this as a divided by b and multiply by the reciprocal of this, which is d divided by c, and therefore a can be simplified with c, because now this is in the numerator, this is in the denominator. That means that these two can be simplified together, and also b and d can be simplified together. This is about simplification. Now, once you simplify things, then you want to rewrite your fraction, right? When you want to rewrite your fraction, that comes the part that I didn't know, that I did not know. Suppose that you have a divided by b and divide that by c divided by d. And of course we said that we could simplify a with c and b with d, right? Now suppose that for whatever reason, you have simplified, for example, a with c. A with c are the same values, you have simplified them, and you've got 1 and 1 over here. Now this is now the same thing as 1 divided by b divided by 1 divided by d, right? Which is basically nothing but, this is not the same thing as b divided by d, but the same thing as d divided by b. Meaning that you have to write this in the numerator now. This becomes the numerator, and this becomes the denominator. Because, and the reason for that is that basically you have 1 divided by b, and when you have 1 divided by b by 1 divided by d, you can write it as 1 divided by b times the reciprocal of this, which is d divided by 1, which is d divided by b. So you can see that this d comes to the numerator, becomes d, becomes the numerator, although it's in the denominator, and b comes to the denominator. So this is something that I did not actually know. I mean, I don't really know what I've been doing so far. I might have done things differently, but it was interesting that I didn't know that, really. And I don't know. I mean, of course, I haven't made any mistakes so far, and I have been doing mathematics for a long time, but there are these little things that you just simply don't know. And so now what that means is that the numerator and the numerator here, I can cancel out, and in order for you to not get confused, I will write this in a different color. And so you can cancel out n factorial with n factorial. This becomes a 1, this becomes a 1. And so now once I want to rewrite these two fractions, I have to write this as the numerator, meaning that I write over here n minus r minus 1 whole factorial times r minus 1 factorial, and divide that by this denominator here, which is n minus r minus 2 whole factorial times r minus 2 factorial, which is equal to 1 by 7, right? Now, regarding these, in order to simplify these, again, you need to take a couple of things into consideration. Okay, so now in order to simplify this part, so suppose that you want to simplify, for example, let's make it simpler. Suppose that you want to simplify n minus r minus 1 whole factorial divided by n minus r minus 2 whole factorial, right? So in order to simplify this, you can see that this is n minus something whole factorial over n minus something else whole factorial. So you essentially, in order to simplify such expressions, you need to basically proceed as follows. So suppose that you have something like, for example, n factorial. N factorial, as you know, is equal to 1 times 2 times 3 times all the way up to n, right? All the way up to n. So this is 1 times 2 times 3 all the way up to n. And so logically, before n, you can see that before 2 you have 1, before 3 you have 2, before 4 you have 3, and so on and so forth. That means that these numbers are basically natural numbers, adding 1 to the number before to get the next number, to get the next number, and so on and so forth. That means that the number that comes before n is 1 less than n, so that is n minus 1. The number that comes before this is 1 less than this, so that is basically n minus 1 minus 1, which is n minus 2, times, for example, n minus 3, and so on and so forth, right? So that basically means that, and you can write this as n minus 0. N minus 0 is equal to n. So you can see that you have these numbers here, 0, 1, 2, for example, 3, and so on and so forth. And as I'm moving in this direction, I'm adding 1 to these numbers. So add 1 to 0, you get 1. Add 1 to 1, you get 2. Add 1 to 2, you get 3, and so on and so forth. Which means that any term that you have here, if you want to get the term before that, you have to add, essentially just add 1 to this number. But you don't touch the negative sign over here. The negative sign remains the negative sign. Whatever that number is, either negative or positive, you just add a positive 1 to it. Add a positive 1 to it. Which means that over here, for example, if I take this factorial over here, n minus r minus 1, basically whole factorial, right? So that would be basically the same thing as 1 times 2 times 3 times all the way up to, for example, this would be the last term, n minus r minus 1. That would be the whole expression. Now, to get the term before this, you have to add 1 to this number over here. If you add 1 to this, you'll get basically r minus 1 plus 1, which is equal to r, right? So that would be n minus r. So basically I can write n minus r over here. Then add 1 to this, I will get basically n minus r plus 1, for example. And basically then you can just keep going in the same direction, of course. Meaning that you can write this as n minus r plus 1, and you can basically do the same thing again, meaning that you can write n minus r plus 2, and so on and so forth, right? So now let's do the same thing with this factorial over here as well. So you have n minus r minus 2 whole factorial, which is equal to basically 1 times 2 times 3 times all the way up to n minus r minus 2, and that is the last term here. Again, if you add 1 to this, meaning that if you write this as n minus r minus 1, you will get the term previous to this. Again, you can add 1 to this, you will get n minus r minus 1, add 1 to it, you'll get r. So you get this term. So you can see that I already got this last term here, over here, right? This is this last, and these two terms are the same. Which means that basically I can write this as, I can suppose that now I was dividing this by this, in which case I would simply basically simplify all of these terms with all of these terms, and then I would get only a n minus r minus 2 in the denominator. So I would basically simplify this with this, and I would get n minus r minus 2 in the denominator. So over here I would get a 1 over here, and over here I would get n minus r. I would get n minus r. I would get n minus r minus 2. And that would be basically this expression simplified. Moreover, you have the same thing over here. If it basically sometimes these are confusing, so you have to write them out so as not to make mistakes. Moreover, when you have r minus 1 factorial, divided by r minus 2 factorial, you can write that as, again, the same thing. So you have 1 times 2 times 3 times all the way up to n minus 1. That is actually r minus 1. And over here I have 1 times 2 times 3 times r minus 2. Right? Now we said that to get the term before this, you have to add 1 to this number. So adding 1 to 1 will give me a not basically taking the negative sign into consideration, only this number here. So adding 1 to 1 will give me a 2, so that's r minus 2, right? And so on and so forth, and so on and so forth. And as you can see, you can simplify these with all of these terms, and you will get r minus 1 in the numerator, and then this would be just the 1. And therefore you have n minus r, this is r minus 1 actually, this is r minus 1, and this is n minus r minus 2 is equal to 1/7. So that basically gives you r minus 1. Divide that by n minus r minus 2, and that is equal to 1/7, right? Which means that basically you have 7 times r minus 1 is the same thing as n minus r plus 2, and so 7r minus 7 is equal to n minus r plus 2, and 7r minus 7 minus n plus r minus 2 is equal to 0, and then 7r plus r is equal to 8r, and negative n, and negative 9 is equal to 0, which means that, so this is negative n plus 8r minus 9 is equal to 0, multiply by negative sign, again n minus 8r plus 9 is equal to 0, right? So that is basically the simplified version of this whole expression here, right? Now, another expression that we can so basically over here I have two unknowns, so I cannot solve for them unless I had some other equation containing the same two unknowns. So for the same reason I can consider, for example, these two over here, which have the ratio 7 to 42, n combination r minus 1 to n combination r. N combination r minus 1 to n combination r, and that is equal to 7 to 42. 7 to 42 of course is 1 to 6, and so you can do the same thing again. So you can basically write this as basically n factorial by n minus r minus 1 factorial times r minus 1 factorial based on basically n combination r is equal to n factorial divided by n minus r factorial times r factorial based on this. And this is again the same thing, so this is n factorial divided by n minus r factorial times r factorial, and then you can simplify these two, and then over here you have 1/6, and then you can again write this as the numerator, n minus r whole factorial times r factorial, divide that by this expression here, n minus r minus 1 factorial whole factorial times r minus 1 factorial, and that is equal to 1/6. And now you can do the same thing to simplify this. You would get some expression, some equation like this, and then you will be able to solve that equation. Okay, so now the next thing that we have basically to calculate, for example, if you have n minus r whole factorial, divide that by n minus r minus 1 factorial whole factorial, that you can write as basically 1 times 2 times 3 times 3 times all the way up to n minus r whole factorial. Actually factorial is not required anymore. and then add 1 to this, you'll get n minus r plus 1 factorial and n minus r plus 2 factorial, which is not going to help me because over here I have n minus r minus 1 factorial, right? So I write this over here as n minus r minus 1 factorial, right? And then there is actually no factorial there. And then basically the term that comes before this, you add just 1 to this number, meaning that n minus whatever you have over here, you add 1 to this number. Add 1 to this number. It could be r minus 1, it could be r plus 1, it could be anything. Just add 1 to it. And that's what I'm saying, this based on the expansion of n factorial, right? So there you would get basically adding 1 to this, you would get an r. So that would be n minus r. That would be n minus r. And if you just keep going, you would get n minus r plus 1, n minus r plus 2, which is of course not required anymore, because I already got this term over here. So that's 1 times 2 times 3 times all the way up to here. And then I can cancel out all of these here. And then so this becomes basically, these two you can cancel out. And so over here you get n minus r minus 1. And that will be these two simplified. Moreover, you can write r factorial by basically r minus 1 factorial is the same thing as, so you know that basically you have 1 times 2 times 3 times all the way up to r, and before that comes r minus 1, and then over here you have r minus 1, so 1 times 2 times 3 all the way up to r minus 1, and therefore you can cancel these two out, and so you have r over here. So there's an r over here, so there is a 1, and therefore you have r over, let me write that up there, and therefore you have r over basically n minus r plus 1 minus r plus 1 is equal to 1 over 6. So that is basically that. If you cross multiply, you'll get 6r is equal to n minus r plus 1, which means that basically 6r minus n plus r minus 1 is equal to 0, which means that basically 6r plus r is equal to 7r minus n minus 1 is equal to 0, or you can write this as negative n plus 7 times r minus 1 is equal to 0 multiplied by negative 1, n minus 7r plus 1 is equal to 0. That you can call n minus 7r plus 1 is equal to 0. That you can call equation number 2. This you can call equation number 1. And therefore you can write 1 and 2 gives basically n minus 8r plus 9 is equal to 0, and n minus 7r plus 1 is equal to 0. And if you multiply by a negative sign here, negative, positive, negative, and then you can cancel these two out, negative 8r plus 7r is equal to negative r. 9 minus 1 is equal to 8 is equal to 0. Negative r is equal to negative 8. R is equal to 8. Now if r is equal to 8, then from 1 we have basically n minus 8 times r, which is 8, plus 9 is equal to 0. N minus 64 plus 9 is equal to 0. 64 minus 9 would be equal to 55, negative 55. That would be negative 55, so n is equal to positive 55. N is equal to positive 55. So that is basically the n over shear that we wanted to calculate. Right? Now, I hope that by now you have understood how to find the nth term, or basically any term of the expansion of a binomial, and how to calculate, basically how to simplify these factorial and combination basically expressions. If you have not, that's not a problem. We have in exercise 8.2 we have 12 exercises here. We will go through them, and then we will, whatever you have missed, we will basically do them together. What's important here is that you need to do these exercises on your own, and sometimes you have to do these exercises more than once to learn them. That's what I've had to do many times in many cases in order to learn the concept here. So I hope that you enjoyed this video. I'll see you in the next video. Thank you.